Thank you, RefComm, for giving me the opportunity to present a paper on tobacco technology and disruptive innovation technology for anti-coking and corrosion minimizations in various refinery fire heaters like delayed coker, whiz breaker, vacuum distillation units, and many other units. And today I will cover this presentation in my slides. Next slide, please. So the agenda for my session is I'll speak a bit about the parent company TUBACEX Spain Group, a bit of idea on what this tobacco technology concept is about, how does it work, some of the product properties in product characterization. Then I'll get to the main topic of coke deposition mechanism that happens in fire heater tubes, then cover the chemical inertness and coking resistance study of this tobacco technology. And then I will take you through some field application case studies that will show you how this technology works in the real world in commercial application. And then next one, I will do some of the corrosion application studies, commercial trials we've done in the field, followed by a conclusion. Next slide. So as you may know, TUBACEX is the world's leading supplier of seamless stainless steel tubes, covering more than 15% of the global market share, with a revenue close to €1 billion, with 3,000 employees and manufacturing mills around the world in 16 different sites, including Spain, USA, Austria, Middle East, India, many other countries, and a commercial presence in over 30 countries. And we cover everything from making our own steel at our mills through the extrusion, cold and hot finishing, and then making the finished products, whether pipes or tubes and fittings, and then supplying to the global network in various chemical, fertilizer, nuclear, refining industry through a commercial network. Next slide. So tobacco, as you can see, the technology where we can coat the tobacco tubes either from outside or inside. And this technology, a disruptive innovation technology, is based on silica ceramic base with many other inorganic metal compounds, oxides made from magnesium, zirconium, zinc, aluminum, potassium, and sodium, a proprietary technology now that's commercialized in many applications around the world. And again, tobacco is 100% owned by the TUBACEX Group. Next slide. So the key part of this technology, one that's patented and also we have engineered the commercial production, is the engineering, industrial development, and commercialization of these tubular solutions of these innovative advanced coatings to give you the outstanding anti-fouling resistance that reduces the deposition in fire heaters like a coker heater or a VDU furnace, and that gives you increased heat transfer and a higher throughput. Chemical inertness that minimizes the coke formation and reaction that makes the coke with the base metal. Excellent corrosion resistance in different harsh medias and high temperature conditions up to 1500 degrees Fahrenheit. And also the abrasion resistance of these tobacco coatings is very good. Hardness is 4 times higher than the base material. By combining these properties, we're able to bring you a long-term, commercially proven, reliable, and a competitive solution to give you that increased value in terms of the life length of the unit and the throughput, and the most common is the reliability that you seek for the unit that you need in very severe conditions and extreme environment. Next slide. Commercial applications, as you can see, oil and gas is our focus, chemicals and petrochemicals, industrial processes, power gen units, nuclear plants, and the fertilizers. And we focus on the tubular solutions within the furnaces, heat exchangers, condensers, boilers, and reactors. And I will take you through many examples as move along in the presentation. Next slide. I will cover the key properties so you have an understanding on why this technology works, how it works, to give that sound solution through this morphological, mechanical, chemical, and thermal properties. You can see the tubes you can coat from inside or outside, depending on where you have a problem, whether it's a corrosion, fouling, coking, or abrasion. Commercially, this technology works very well. Next slide. So one of the key properties is we have developed the manufacturing know-how such that we're able to apply a very thin layer, about 150 microns average, 0.15 millimeter across the length of the pipe, which we control through a unique process where we're able to do ad hoc housing automated process where we can spray around 360 degrees across the length of the pipe and give you that unique thickness and a surface area that you require without any quality issues and maintain those rheological properties. Next slide. One of the key properties is the roughness of the surface. As you can see on the screen, on my left is a substrate tube, carbon steel or a stainless steel that's not coated. On my right is a same tube that's coated. And what you see is by having this advanced tubular coating, we're able to reduce the roughness by 97%. What that means is having a glass like this very fine finish, it minimizes any resistance to the flow. Also, by doing so, it minimizes any foulants or contaminants to deposit on the tube surface. And that's why you have a much less fouling or tendency to foul on a tube surface. Next slide. One of the very important properties, in refining and petrochemical processes, you have significant velocities, you have significant angles going from 0 degrees to 180 degrees. And in the process with these higher velocities, corrosive material and different angles of impact, you have a significant abrasions of the base material. What I'm showing on the screen is, if you see on my screen, on the left is on the top is uncoated area, at the bottom is a coated area. And what I show is by using TUBACEX technology, you are able to reduce the abrasion by 94%. And this test is done over 10,000 cycles. 94% decrease in abrasion is a significant improvement to give you the much longer life of the base material using TUBACEX technology. Next slide. The hardness, if you look at the coating hardness in this particular slide, is over 800 Vickers number compared to 220. And that abrasion resistance is significantly higher with the 4 times the hardness. A very important property to have for your harsh conditions in your refining and petrochemical processes. Next slide. All the refineries and petrochemical units have heat exchangers, thousands of them in every process, in every refinery, in every petrochemical plant. And one of the key problems is the fouling of these heat exchanger tubes, more so from inside and also from outside, depending on where the problem is. The TUBACEX glass finished layer will allow you to protect the inner or the outer surface of the tubes. One, the deposition rate for foulants will decrease because of the chemical inertness and the smoothness of the surface. Also, the removal rate of foulants or contaminants or particulates will increase due to its anti-adhering properties. By doing so, your heat transfer efficiency will increase, your heat transfer loss will decrease, giving you much better heat transfer efficiency, reduce fuel consumption. And also at the same time, by having these fluid flow properties, or fluid flow will maintain increase in the stream, giving you the desired optimum throughput. Very important for the heat exchangers. Next slide. Again, the rate of fouling, very important key parameters for the heat exchangers. As you can see from this slide, for a given velocity, the rate of fouling for the tubular solutions or the tubacode is 3 times lower. The red dots I show here on the screen is the rate of fouling for the tubacode tubes, and the blue dots or the diamonds are for the carbon steel. And you can see significant higher fouling avoidance of coated samples, a very important property to have to prevent the fouling. And that's very clearly shown here with the study we did over 7 months. Next slide. In summary on the properties, by having the coating, a proprietary coating with the silica ceramic based advanced solution, and then having those vitrified over 1470 degrees Fahrenheit, we're able to bring you this technology, which provides a chemical bonding and glass-like properties. And because of this chemical bonding and low porosity, it gives a very good corrosion resistance. As you saw, the roughness is reduced by 97%. The coating material is inert. That gives you a very good caulking resistance and a clogging resistance. Hardness is 4 times. That's very good property to have against the abrasion resistance. And since this technology is proprietary, have multiple steps involved in making the technology, this coating is primarily done at our plant in Spain. It's an on-site application in the sense we make this coating work in our factory and not at the customer site. Next slide. Now let me talk to you about the coke deposition in fire heater tubes, a very key problem. Anybody who has a whiz breaker or a delayed coker or a vacuum unit, they would have this common problem with the coke deposition. Next slide. So in simple schematic, what I'm showing you here is a DCU or a VB or a VDU furnace where you have a low value feedstock, whether it's a vacuum residue or atmospheric bottoms. Heavy low value feedstock with the high carbon goes through a DCU furnace or a whiz breaker furnace. You make high value product, whether it's a high distillates. In the process, you create a lot of coke, and that coke deposition on the furnace tubes is what fouls the tubes. Next slide. So the mechanism you can see on the screen through a tube in the furnace, as the coke layer goes, you will see the heat transfer efficiency will reduce. Your tube skin temperatures will go up. You will have hot spots, and effective heat transfer area will be reduced. Then you will have also a high pressure drop because of the coke deposition, and ultimately then you're losing efficiency loss. You can no longer run the throughput that you desire, and you're running the end of run conditions, and it's a time then either for going for a decoking, where it's the online spalling, steam air coking, or mechanical pigging. And the cost of this pigging, if it's a mechanical pigging, it requires a shutdown. Average cost is about $1.6 million. If it's an online spalling, that requires again a throughput reduction, it's costing you a refiner to an end user about $0.6 million. And this is typically the values for a 20,000 barrels per day delayed coker unit. So it's a huge cost to an end user or to a refiner to having this on frequent spallings and pigging operations. They're not desirable. Next slide. Also, many people use different metallurgies. 9-chrome is one of the metallurgies commonly used. Also, there is a 347H material, and 347H certainly gives you a longer run, about 100 degrees higher operating temperature window. But at the same time, you have to remember, no matter what substrate or steel that you use, it promotes the coke forming reaction because they are active surfaces. They play an active role due to polymerization and condition of aromatic compounds. By having a tubacoat technology, you are preventing these reactions because tubacoat is an inert material between your substrate tubes and the feed that's coming in. And that's how we're able to control the fouling and the coke formation. Next slide. Now let me show you a chemical inertness and coking resistance study we did with the European University, and the results are quite conclusive in the sense they show very clearly how the tobacco technology works. Next slide. So anti-coking solution, what my presentation is today based on in a key area. When the coating is applied to the inner surface of heater tubes, it minimizes the coke forming reactions because the coating is chemically inert. That's one. Now, one is a coke formation reaction. Second part is a coke deposition. By having a very smooth glass finish surface, we're able to use that anti-fouling property to minimize the coke deposition also. And by doing so, we're able to bring you at least 3 to 4 times longer run length before spalling or pigging, 1 to 2% savings on the fuel consumption, and that's a reduced CO2 footprint, and of course, increased safety and reliability because you don't need as many shutdowns, unplanned shutdowns, and maintenance activities and human activities. So it's a threefold benefit on all the fronts. Next slide. So we did a study on these reactions where we took a dimethyl ether, a chemical compound, and if you crack it proper to methane and carbon monoxide, you don't make any coke or carbon. But that's not what happens in the real life. Your metal is reactive. You have a lot of side reactions, and you can see the side reactions make a lot of carbon and coke, and that's what is not desirable in the furnace tubes. Next slide. So the conclusion of the study, what we saw was chemical inertness of the coated tubes or surface. It avoids the coking reactions. And when you shut down the delayed coker unit or a whiz breaker and vacuum unit and start again with the coated tubes, your startup run temperature will remain the same, and it will not promote the coke forming reaction. Whereas for the uncoated tubes, your coke forming reactions will start much earlier than the cycle before because your metal has become now very active in promoting those reactions. Also, you can see the coke formed is 10 times lower. On the slide, you can see 10 times lower. So there's a factor of 1 magnitude. Second part is the carbon deposition. Carbon deposition is so low that even in the chart, I can barely show the deposition. It's 100 times lower. So it's a significantly lower carbon deposition. That proves this technology really works in minimizing the coke formation and coke deposition in the heavy processing unit fire heater tubes. Next slide. Now let me take you through some commercial applications and field studies. Next slide. So this is a whiz breaker, a 15,000 barrels per day whiz breaker at a refinery in Europe. They had a significant problem with the coke deposition inside the tube that causing the frequent shutdown and loss of production. Also, the preheat exchanger they have will also plug up due to coke accumulation. So we supplied them ID coated tubes, bends and flanges, as you can see in the screen, Metallurgy 317 stainless steel, and let's see the outcome on the next slide. After 10 months, what we saw was 75% reduction in coke deposition. The coke layer was so thin, it could not be even detected by radiographic test. Coke was much easier to remove just with the water pressure and not without any requirement for the mechanical instrument. And what we prove in the process is run length, because they've been running now 6-10 months without having to decoke. The run length between 3 to 4 times, savings are close to $1.5 million on significant accounts, higher throughput, a reduction in the furnace online spalling, reduced fuel consumption, and heat exchanger cleaning benefits because they don't have to clean the heat exchanger. Next slide. This is another delayed coker in Asia, one of the largest with the 124,000 barrels per day. Heater material is P9. Let's see the next slide. So this customer also required pigging every 3 months and online spalling every month. During the pigging, they shut down the unit for 3 to 4 days and the unit runs at 70% capacity. During the spalling, they run 93% capacity. So the cost of pigging for them is $3.6 million per furnace, and spalling is about $125,000 per furnace. A significant cost to a refiner not able to run a throughput they desire. Next slide. So we did the technical evaluation, we did the simulation runs, and we did the overall evaluation. And what we found was, by using a tobacco technology, this particular customer in Asia would save on average about $10 million per year, $50 million over 5 years, including the cost of the tobacco technology. Next slide. And this customer now is running their operation for more than 6 months. They have completed the online spalling. They also completed the mechanical pigging. And I'm glad to inform that this coating can withstand online spalling. It can also withstand mechanical pigging. And mechanical pigging can be done using decoking pigs with the stainless steel studs. More details on the next slide, please. So thermal shock resistance. The interesting thing about our technology is the coating has the same coefficient of expansion as the base material. And what you see on this particular slide is during the startup and shutdowns, you have a rapid increase in temperatures and rapid drops. Like in less than 10 minutes, you go from 0 degrees to 700 degrees Celsius, which is close to 1400 degrees Fahrenheit, and you drop the temperature again. But absolutely no problem with the coating, no damage, no cracks, and they work very well because we have designed the same coefficient of expansion as the base material. Next slide. And as I said, pings with the tungsten carbide studs are no longer required when you use the tobacco technology because the coke that's formed is much softer and easy to remove. And so we recommend using the stainless steel studs. And we already done the decoking, mechanical pigging, and there is no damage of coated surface, and it works just perfectly fine. Next slide. Another delayed coker in Asian refinery, again, is a P9 material. For about 50 days in a year, they run at 85% throughput because of the online spalling, which they do every 50 days. And during that time, they run 85% throughput. Just the cost of throughput is $3 million per year. We've done the similar evaluation for this customer, and the benefit again is significantly higher. Payout is in less than 1 year. They plans to install tobacco in 2022 turnaround. Next slide. Another delayed coker in USA refinery where they have a 347H material. They do 4 spalls per year and 1 mechanical pigging. And the mechanical pigging, they shut down the unit for 6 days. During that time, throughput is 75% reduction at the 75% for, and that's significant. That is for the spalling. And then 6 days for the shutdown. This particular customer, the cost is $2.5 million per year. Net value savings by using a tobacco technology. They would also be installing the tobacco technology in 2021 timeframe. Next slide. The VDU furnace, vacuum distillation unit furnace in a Canadian refiner. They had a significant problems with the severe coke formation causing their outer lines to plug, and they had to replace these lines, not only the fouling, but the corrosion also. Also, they have a traces of polyethylenic acid stress corrosion, and they tried many other things, and then they end up with using a commercially proven tobacco solution where we supplied the inner coated tubes bends and reducers. And now this customer is running now almost 6 months. So far, no problems at all. Base metallurgy 317, and we expect return on investment in 1.5 years. Customer is very happy with the performance so far. Next slide. Another VDU furnace in Europe, another refiner. Now 317 stainless steel. They've been running now for more than 2 years, and they have not had any need yet to do the cleaning or pigging operations. Again, proving the TUBACEX technology is holding very well in this particular VDU furnace heater. Next slide. This is a rigid hydrocracker in North America, in particular Canada again, and what it shows is here is an issue around the abrasion. So they have about 800 rigid hydrocracker reactors, risers, and these risers, they face significant velocity, and that causes severe fouling and abrasion of these risers, and that leads to a maldistribution, not giving you the desired conversion from the rigid feed to the distillates. And the cost is significant to them. Even if a 1% drop in the conversion means a huge money. Currently, we're working with them in developing, applying our technology, and this customer planning to apply the TUBACEX technology on the rigid hydrocracker in 2022 timeframe. Next slide. Now, I covered a lot of anti-fouling, anti-coking application. Also want to show you that this technology is effective in also corrosion applications. Let me take you through a couple of corrosion applications that we've done commercially. Next slide. So this is a coker calciner, again with the refinery in the Washington state. They had a huge problem with their recuperator heater, where they have the chemical corrosion with the vandates. Also a very high temperature of 850 degrees Celsius, close to 1600 degrees Fahrenheit. Metal surface skin temperature is 570, about close to 1200 degrees Fahrenheit. They were using TP310. They tried every metallurgy and it didn't work. They had to change these tubes every few months. We happened to meet them in a conference like a RefComm, and they said, we tried everything, let's try the TUBACEX technology. Next slide. So we applied initially a trial of only 9 coated tubes. And when you see these coated tubes after 10 months in operation, what you see is TUBACEX tubes are very intact, whereas the uncoated tubes are either damaged, blinded, or melted. And this trial convinced our customer that the TUBACEX technology was a very good fit for their process on the coker calciner recuperator. Next slide. So as much as they liked our technology, they installed 800 tubes. You can see the tubes in 2 different colors. They're designed for 2 different temperatures. And you would see the status conclusion in the next slide, please. So what you see here on the screen is by installing the TUBACEX technology, when you look through a furnace window, you can see a unique temperature profile, no hot spots, no damage to the tubes, and that's a very good maintenance reliability, and that give them 3 times the cycle length, savings of $2 million a year. And now this big refiner has become a regular customer of TUBACEX and TUBACEX group of companies, and they're very happy with the performance. Next slide. Let me show you another good example of anti-corrosion. This is a European energy plant, and if you look at the conditions, they have temperatures close to 850 degrees Celsius, close to 1600 degrees Fahrenheit. This is a waste to energy plant, so there is a lot of corrosion and a lot of fumes. And this corrosion causes, of course, having to plug the tubes. That's the efficiency loss. And they were already using a 16 moly cladding with the in-coronal cladding. Let me show you the comparison with the tobacco in the next slide. So here is a side-by-side comparison. On center, you have 16 moly. On the sides, you have a tobacco coated tubes. When installed, everything looks good and brand new. Now take into the account the inconel overlay cladding. One, the surface is very rough, so it will cause foulants to deposit. It will promote corrosion. Secondly, the heat transfer will be significantly reduced because of the material is so thick. The next slide. After 2 years in the operation, what you see on the screen is the tobacco tube is as good as brand new, whereas moly with the inconel cladding, you see the significant corrosion of the tubes to the point they would have to replace them. So customer really like this outcome. Let me show you after 4 or 5 years in the service. Next slide, please. And after 4 years, what you see is tobacco tubes are intact, absolutely across the length of the tube, very negligible mass of loss, and excellent corrosion resistance, homogeneous performance across the length, and no ash adherence, confirming much longer tube length, much reliable operations, no unplanned shutdowns. And this has now been running now more than 6 years in this energy plant. Next slide. So in conclusion, anti-coking, anti-fouling, and corrosion minimization, this commercially proven tobacco technology is very profitable because it allows you to run length that you desire, 3 to 4 times higher run length. Also, it's very safe because it reduces the number of shutdowns, reduces the unplanned shutdowns, and also the human involvement because you are not doing so many shutdowns. Also, the hot spots are reduced. That's another safety feature you have when you use the tobacco technology. Process is clean in the sense it reduces the fuel consumption, and that gives you higher heat transfer efficiency and also reduced carbon dioxide footprint. Reliable, so much so that now major US companies and refiners around the globe are using this technology. And again, keep in mind this technology is just 0.1 millimeter in length and gives you that additional protection to the existing base material. Next slide. Again, this is the plant where we do this disruptive, innovative tobacco technology. Is based in Cantabria, Spain. It's a northern Spain, and you can reach out to me on the screen with my details. I want to thank you all for attending my session. I want to thank you sincerely, RefComm, to give me the opportunity to present tobacco technology, and I look forward to working with you. Thank you.